This call is now being recorded.
Okay, once again, good morning, all. So, we have started the chapter number 4, which is called as a work measurement. And in this particular chapter, we have discussed one of the important method, which is called as a time study. So, basically, this particular chapter is mostly concerned with the time required to perform the task. There are two concepts are there. One is the method study and another is the work measurement. So the method study means we have discussed to eliminate the unnecessary operations. And this particular chapter number 4 is deals with the time required to perform the operation. So whenever we are working on any type of operation, whenever we are handling any type of machine, so how much amount of time is required to complete that particular task? That time we are going to calculate by using this particular chapter number 4, which is called as a work measurement. And in this particular chapter, we have discussed the first method, which is called as a time study. That is, we have discussed related to the different types of the instruments are there. That is, stopwatch is there, time study board is there, time study sheet is there. That we have discussed in the last 2-3 lectures. Then in the last lecture, we have discussed about the different types of the allowances. So whenever we are performing the task, so at that time, if you have to go for the drinking the water, if your breakage of the tool is taking place, if you have to change the tool, if you have to change the coolant, oil, like that, some unavoidable activities are also there. So at that time, the different types of the allowances also it is provided. So if I have to measure the total standard time, so standard time is equal to basic time or the normal time plus allowances. So like that simple formula is there if we have to calculate the standard times. So now in the today's lecture, we will discuss about the second method of the work measurement, which is called as a work sampling. So the work sampling is also called as a sampling activity. So this is the second techniques which is used in the work measurement in order to find the time required to perform the task. So this particular second method, it is applicable for the man and the machine. So this is the second method which is applicable for the man and the machine. Means, what is the meaning of that? So whenever operators are working on any type of machine, how much amount of time is required to complete that particular task by that operator, that we are calculating. Also, sometimes the machines are continuously working. At the start, in the morning, we are starting that particular machine, and in the evening, we will stop that particular machine. How much amount of time that machine is in working condition, that also we are going to calculate by using this particular work sampling technique or the sampling activity. So in this particular method, so the number of observations are made. The work sampling is one of the technique in which the number of observations are made over a period of time. So what is the meaning of that? Number of observations are made. That means whenever your first shift is started, maybe your shift is started at morning, maybe at 8 a.m. So whenever your first shift is started at that time, the number of machines are started. Then operators are also working on that particular machines. So at that time in the morning session, whatever the supervisor is there or whatever the management person is there, that management person or the supervisor is visiting to that particular uh, workstation, or he is visiting to that particular production department, and he is observing how much machines are in working condition and how much machines are in idle condition. So, and it has been observed in morning session, it has been observed by, that is 90% machines are in working condition and 10% machines are ideal. That means still that 10% machines are not started. So this is the first observation. It is made by the supervisor in the morning session. Again in the afternoon session, maybe in the second shift, again the supervisor is coming. Again he is checking that how much percentage machines are working, how much percentage machines are idle. Again, it has been observed that 90% machines are in working condition and remaining 10% machines are again in the ideal condition. So this is the second observation he has made in the second shift. Again in the third shift, maybe at the evening session, again the same supervisor is coming, or second supervisor is coming. Again he is checking that how much percentage machines are working and how much percentage machines are ideal. And again the third observer, third supervisor, he has also observed that again the 90% machines are in working condition and remaining 10% machines are ideal. That means three times the same observations are made. Therefore in the work sampling, instantaneous or the observations are made over a period of time. That means in the morning session observations is taking place, in the afternoon session again the same observations are taking place, in the evening session again observations are taking place. That means number of observations are made over a period of time, and from that particular number of observations, it has been observed that the 90% machines are working and remaining 10% machines are ideal. And if we will make that particular number of observations over a period of time, you will get some detailed information like how much machines are in working condition and how much machines are in ideal condition. And from that, one more observation by which percent the workers are working and by which percent the workers are in ideal condition. Therefore, the work sampling or the sampling activity is one of the process in which only number of observations are made over a period of time, and from that particular number of observations we have to identify that in the percentage how much workers are in working condition, how much workers are in ideal condition. This is related to the workers. Similarly, how much machines are in working condition and how much machines are in ideal condition. But for that purpose, what is the requirement? We have to take the number of observations. So if we are visiting to that particular production department once in a day, 4 times, 5 times, 6 times, according to that number of visits, we have to identify that percentage of working and the percentage of ideal condition. Therefore, in the work sampling, it is one of the process in which the number of observations are made. You know about the sampling operations. So you know about the sampling operations, the lot of the products are available, and from that number of products, we have to choose the one product and we have to go for the measurement. You know the sampling. Sampling, it is one of the activity which is performed in the industry. That is, the 100 products are available, and from that 100 products, you are taking the 5 products, we are measuring the dimensions. If that all the dimensions are as per the requirement, it is satisfied, then that total 100 products are selected for further process. But whatever the 5 samples are you have selected for the measurement purpose, and all the 5 samples you will get the different results. Maybe sample number 1, different dimensions are there, 2 different dimensions, 3rd different dimensions. If all the 4 samples you will get the different readings, at that time the total 100 products will be rejected. So such types of the sampling activities are performing in the production departments for the acceptance purpose and for the rejection purpose. Same concept is somewhat implemented here in case of a work sampling, in that only number of observations are made in the production department, and from that particular number of observations we have to identify that in how much percentage machines are working, in how much percentage mans are working or the operators are working. Similarly, in how much percentage the machines are in ideal condition, and in how much percentage your operators, workers or mans are in ideal condition. And from that, finally, we can say that how much amount of time is required to complete that particular task. So therefore, the work sampling and the sampling activity, it is mostly used in the industry related to the number of observations. In case of a time study, we are measuring the time study equipments. Maybe we are using the stopwatch, we are using the time study board, we are using the time study sheet. That means detailed reading we are noting in case of a time study concept. But in the work sampling, we are not measuring the actual reading by using the stopwatch, by using the time study board, by using the time study sheet. Only supervisor or the top management purpose is visiting to that particular production department number of times in one day, and from that visits only he is identifying that percentage of working condition and percentage of the ideal condition. So this is the basic difference between the time study and the work sampling. Then here the 3 applications I have written for the work sampling. The first application is activity and the delay sampling. So whatever the activities operator is performing, maybe he is performing the number of operations. One operator is performing the draining operation, second operator is performing the piecing operation, third operator is performing some another operation. That means each and every operator is performing the different operations or he is performing the different activities. So whatever the activities he is performing, their sampling is also taking place by using the work sampling method. And delay sampling, so whenever operators are performing the number of operations due to some unavoidable activities, maybe the breakage of the tool, breakage of the oil, finishing of the oil, finishing of the coolant, like that so many activities, unavoidable activities are generated. So at that time the delay is taking place in that particular operation. So how much amount of delay is taking place, that is also observed by that particular supervisor. Therefore, whatever the activities we are performing, and during that particular activities, whatever the delays are obtained, that is also calculated by using this particular work sampling activities. Then second application is the performance sampling. So here we are checking the performance of the operator. Here we are checking the performance of the operator. That means whenever I have to check the performance of the operator or worker or sometimes supervisor, at that time this work sampling plays very important role. So when one supervisor is visiting to the production department and he has observed that this is the machine number 1, this is the operator number 1, he has started his job at 8 a.m. and once the same supervisor is once again visiting to the same production department and he has observed that this operator number 1 is continuously working on that particular machine number 1. That means he can say that the performance of that particular machine number 1 and the performance of that particular operator number 1 is very good, or it is excellent. That means he is checking the performance of that particular operator, whether he is continuously working or not. If he is continuously working, then we can say that the performance of that particular operator or the performance of that particular machine is good, better, excellent as per the requirement. But in the first visit, the operator is working. In the second visit, that machine is totally stopped, operator is not working. Again in the third visit, the machine is totally stopped, operator is not working. Then we can say that the performance of that particular machine number 1 is not as per the requirement. Performance of that particular operator is not as per the requirement. So based on this, we can go for calculation of the performance rating. And third important application, it is very important, that is work measurement. This is the requirement. Whatever the task that operator is performing, how much amount of time is required to complete that particular task, that time means work measurement, that also we are calculating by using this particular work sampling. So these are the 3 major applications. So to measure the time required or the time required for the activity, and the delay sampling also we are going to make. Then performance sampling, that means we are checking the performance of the operator as well as performance of the machine. And last important application is related to the work measurement, where we are calculating the actual time required to perform that particular task. So these are the 3 major applications of the work sampling and the sampling activity. Now we'll discuss about the detailed procedure. So this is the procedure of the work sampling. So whenever we are implementing this particular work sampling in the industry, so at that time, this is the procedure which is implemented. So what is the first step? Formulate the objective of the study. So whenever we have to implement this particular work sampling concept in the industry, first of all, you have to decide the objective. So for which purpose I have to implement this particular work sampling in the industry, whether I have to check the performance of the operator, whether I have to check the performance of the machine, or whether I have to go for the time measurement, or whether I have to go for the sampling of the activity or the delay sampling. So first of all, what is the first step? We have to decide our objective, for which purpose I have to implement the work sampling in the industries. Then second step, involve the concerned personnel. Involve the concerned personnel. That means here, which performing this particular activity, whether operator is involving in this particular method or whether supervisor is involving in this particular method. The operator is continuously working on the machine. Third person, supervisor or the management person, he is visiting number of times, means here involve the concerned personnel. Those who are observing that particular number of observation, that person also we have to involve in this particular work sampling process. For the observation purpose, if the person is not available at that time, it is not possible to implement the work sampling process in the industry. That observer is the third person. That operator does not act as an observer. The operator itself does not act as an observer. The task of the operator is only to perform the operation. Supervisor is coming and he is only doing the number of observations. Therefore, the second step is involve concerned personnel. Means here we have to involve one supervisor or one management person in order to observe number of things at the number of times. Then third, fix up the work element and state clearly elements. Fix up the work elements. So whatever the number of elements are there, that means one task we are performing. In that particular task, so many elements are there. So work element number 1, element number 2, element number 3, element number 4. That means number of observations. So first task is completed, then you have to work on the second task. If the second is completed, then you have to move for the third, fourth, like that. So what is the first requirement? Fix up the work element and state the clearly elements. So whatever the number of tasks we have to perform, that first of all we have to decide, and according to that we have to go for the number of observations. If your task is not ready, if your sequence of operation is not ready, at that time it is not possible to go for the number of observations. So first of all we have to fix up the work element, which work we have to perform, and we have to clearly state that these are the 5 activities I have to perform in this much amount of time. So the third step indicate that fix up the work element and state the clearly elements. Number of elements, whatever the number of tasks we have to perform, that we have to decide. Step number 3. Then fourth step is decide the time frame of the work sampling. So here the work sampling is one of the techniques which is used for the work measurement also. The work sampling technique is used for the time measurement also. Therefore, the fourth step is written in the form of time frame. That is, decide the time frame for the work sampling. So whenever the supervisor is coming, so to that particular supervisor, we have to decide the time frame. At which period? For example, the supervisor is coming in morning session from 8 to 9 a.m. Then in the afternoon session, he is coming from 1 to 2 p.m. and in the evening session, he is coming from 4 to 5 p.m. Like that, we have to decide the time frame of that particular supervisor, and in that particular time period, the supervisor can be visit. So in the morning session, he will visit. In the afternoon session, he will visit, and in the evening session also, he will visit. So during that particular visit, whatever the time is required, that time frame also we have to decide in case of a work sampling. Then determine the desired accuracy and confidence levels of the final result. So after the observation, the supervisor is visited and he will give some of the results. So at that time, so whatever the results, whatever the observations he has obtained to that particular results, we have to decide their accuracy and we have to decide the confidence level. So whatever the results are given by that particular supervisor or the management person, so to that particular results, we have to check the accuracy and we have to check the confidence level of that particular operator. Then next step is make the pilot study to the preliminary estimates of the percentage and the delay to be measured. So pilot study means initial experimentations we have to perform, preliminary experimentation we have to perform, and from that we have to find the percentage and the delay to be measured. Percentage error. So in the morning session, supervisor is visited. He is having some results. In the afternoon session, again he is visited. Again he is having some results. In the evening session, again the supervisor is visited. Again he is having the 3. That means 3 results he is having in the morning, afternoon, and in the evening session. And from this particular 3 results, we have to obtain the percentage error and we have to obtain the delay to be measured. In the morning session, how much delay is obtained? In the afternoon session, how much delay is obtained? In the evening session, how much delay is obtained? So like that, we have to check the delay. Similarly, we have to check the percentage error in the morning session, afternoon session, and in the evening session. So like that, the preliminary experimentation or a pilot study we have to made in this particular work sampling. Then design the actual study. Design the actual study. So here in this particular step, we have to go for somewhat modifications. So up to this pilot study, the number of observations are made. After the number of observations, it has been decided that the large amount of delay is taking place, large amount of error is to be taking place. At that time, that supervisor or that particular engineer is visiting to that particular machine, he is visiting that particular operator, and he is giving some suggestions. And according to that particular suggestions, we have to go for the further modifications. And means we have to design the actual study. That means here somewhat modifications are taking place in this particular work sampling. or in that particular study. Then make the observations according to the plan, analyze and summarize the data. Once the modifications are taking place, redesigning is to be taking place. Once again, we have to go for the observations according to the plan. Whatever the plan we have decided, we have to analyze and summarize the data. So if the number of observations are taking place, from that particular number of observations, you will get some data, and we have to analyze and summarize that particular data for your further study. Then second last step, check the accuracy and precision of the data at the end of the study. At the upper side also, we have checked the accuracy. In the second last step also, we have checking the accuracy and the precision of the data, whether obtained data is having the some amount of accuracy or not, whether it is having some precision or the obtained data is as per the requirement or not. That we are going to check in the second last step. And last, prepare the report and state the conclusion. If all the data, if all the observations, whatever we have made, if it is as per our requirement, then at the end we have to prepare that particular report and we have to give the final conclusion. Like in the sense, I have given the example, 90% machines are working, 90% machine, 90% operators are working condition, but remaining 10% machines are in ideal condition, and remaining 10% workers are also in the ideal condition. So like that, we have to give the report at the end, that is prepare report and state the conclusion. So like that, we have to implement this particular work sampling techniques in the industry in order to check the activity and the delay sampling. Then second application we have discussed, that is performance sampling, and last one is called as a work measurement. That means in all the three concepts, if we have to go for the number of observations, if I have to go for the delay required during the operations, if I have to check the performance of the operator, if I have to check the time required to complete that particular task, all that particular activities, it can be obtained or it can be performed by using this particular work sampling procedure. And final results you have to state in the form of reports, and we have to give the final conclusion. So here in this particular techniques, we are not using any type of instruments, we are not using any type of sheet, we are not using any type of board. Only number of observations are made over period of time. In one day, 4 to 5 times we have to visit to that particular production department, and we have to observe all the things in working condition, and through this particular observations only we have to give the final results in the form of percentage of working and the percentage of the ideal condition. Therefore, this work sampling techniques is mostly implemented for checking the performance of the man and the machine. In addition to that, it is also used to measure the time required to perform that particular task. So this is about the work sampling procedure, which is the second techniques of the work measurement. Okay, so this is the detailed procedure. And then we'll discuss about the last techniques or the last method of this particular work measurement, which is called as a predetermined motion time study. Predetermined motion time study, which is in short, it is called as a PMTS. P means predetermined, M means motion, T means time, S means study. It is also called as a PTS. PTS means predetermined time standard. The meaning of PMTS and meaning of PTS, both concepts are same. Predetermined motion time study, PMTS, and PTS means predetermined time study or predetermined time standards. So this is the third techniques of the work measurement, which is also used to measure the time. But the name itself suggests that the predetermined motion time study means here are checking the time required for the operator whenever the movements of the operator from one location to the second location, from second to third, third to fourth, like that. Whatever the motion is taking place, to that particular motion, how much amount of time is required, that we are calculating by using the predetermined motion time study. But from where this particular concept is generated? So here one concept is there, introduction to MTM. So what is meant by MTM? Method time measurement. Method means which method we are using to convert your raw material into the finished goods. Method means which method we are using to convert the raw material into the finished goods, and to that particular method, how much amount of time is required, which is called as a time measurement. Therefore, MTM, method time measurement. This is one of the important concept which is introduced in 1948. Method time measurement, it is one of the important concept which is implemented or which is to be developed in 1948 for the time measurement. And afterwards, MTM1, MTM2, MTM3, MTM4, like that modifications are taking place. The first MTM concept is developed in 1948, and afterwards, as per the requirement of the industry, the modifications are taking place. And once the modifications are taking place, it is represented as MTM1. Again, if somewhat modifications are taking place in that particular concept, again it becomes MTM2. If again the modifications are taking place, it becomes MTM3. Again the modifications are taking place, it becomes MTM4. So like that, number of modifications are taking place, and accordingly the name will be given in the form of 1, 2, 3, 4, like that. And this PMTS, predetermined motion time study, it is one of the application of this particular MTM process. So what is the meaning of the predetermined motion time study? Before starting your activity, we have to analyze that how much amount of time is required to complete this particular task. And like that, observations also we are make in our day-to-day application. For example, if I have to go to the Solapur from the Pandharpur, so what we are deciding in your mind? So I have to reach in the Solapur at 1 p.m. I have to reach in the Solapur at 1 p.m. How much amount of time is required for the traveling? 1 hour and 30 minutes. So like that planning we are making in your mind, we are analyzing that particular time. Within 1 hour and 30 minutes, I have to reach in that particular Solapur. That means still you have not started your traveling. Still you have not started your activity. Just we are reminding in your mind, just we are analyzing, I have to reach into the Solapur up to the 1 p.m. and the total time required for the traveling is 1 hour and 30 minutes. But your traveling, your activity, still it is not started. That means before starting the activity, if I am calculating the time to perform that particular task, that concept is called as a predetermined motion time study. Predetermined motion means before starting your activity in advance, if I am calculating the time, that concept is called as a predetermined motion time study, or also it is called as a predetermined time standards. And like that activity we are using in our day-to-day application. Whenever we are performing any task, we are deciding the time. I have to complete this particular task within 1 hour. I have to complete this particular operation within 3 minutes. That means your operation is not started, your task is not started. Then also we are deciding in your mind, that is, I have to complete this particular task within 1 hour. That means in advance we are deciding the time. Therefore, this particular third method is called as a predetermined motion time study. Okay, so like that, this particular method is mostly implemented in the industry, because whenever we have designed any type of method, for example, you have to convert one raw material into the finished goods. But whenever we are converting that particular raw material into the finished goods, first of all, we have to decide one rough time. That is, I have to convert this particular raw material into the finished goods within 1 hour. I have to complete this particular raw material, or I have to convert that raw material into the finished goods within 1 hour. That means 1 hour is given to that particular operator. This is the one sample time. It is given to the operator. Sometimes that work can be completed in 45 minutes only, but sometimes that work can be completed in 1 hour and 30 minutes. That means extra 30 minutes that work has taken. But whatever 1 hour I have decided, this is the rough value I have decided. 1 hour is the rough value, and that rough value we have to decide under the category of PMTS. So in the industry, so whatever the number of machines are there, whatever the number of operators are there, for each and every object, one rough time is decided. So we have to complete that particular job in 2 hours. This is the rough value. 2 hours is the rough value. Sometimes that job can be completed in 1 hour and 30 minutes. Sometimes that job can be completed in 2 hours and 30 minutes. But rough value I have decided as a 2 hour. Because in that particular 2 hours, sometimes the breakage of the tool is taking place, finishing of the oil is there, finishing of the coolant is there, operators are taking the rest, so extra 30 minutes are required. And if I will complete that particular job in 1 hour and 30 minutes, so maybe that job is very small, that operator is continuously worked on that particular object and he has completed its task within 1 hour and 30 minutes. But whatever the 2 hour rough value I have decided, that rough value I have to decide under the concept of predetermined motion time study. That means before starting my task, before starting our activity, just we have to decide a rough value, rough time to complete that particular task. And that concept is called as a predetermined motion time study. This method is having the 4 major advantages. That first one is a short cycle timed accurately. So whatever the short cycles are there, that cycle can be completed within 10 minutes, 15 minutes, 45 minutes, max up to 1 hour. So that cycles are called as a short cycle. So for that particular short cycles, this PMTS method is mostly used in the industry. So if your cycle is, your job is very large and that job is taking maximum hour, maybe it taking the 4 hour, 5 hours. So for such types of the activity, this PMTS is not implemented. So whatever the short cycles are there, maybe that job can be completed within 1 hour. So for such application, for such jobs, this PMTS plays very important role. Then second, rating most difficult part of time study not required. Rating most difficult part. So whenever I have to give the rating to that particular most difficult part, whether that part is completed within time or not, that also I am going to check by using this PMTS concept. That's why I have given the example. Rough value is given, that is I have to complete that particular job within 2 hours only. If the same job is completed in 1 hour and 30 minutes, we can give the good rating. So job can be completed in 1 hour and 30 minutes. But sometimes the same job is taking the time 2 hours and 30 minutes. That means extra 30 minutes are taken by that particular same job. So why it is to be taking place at that time, we have to reduce the rating of that particular part only. So whenever I have to give for the rating, whenever I have to give the ratings, at that time this PMTS also plays very, very important role. Then third advantage, the results obtained are consistent. This is very important. So whatever the results you will get from this particular PMTS, these are whatever the obtained results are there, they are all the results are consistent results. And last important advantage is that a reasonable estimate of the work content can be obtained before the task is actually carried out. I have given the example. Before starting your activity, before starting your task, before starting your machine, before starting your job, whatever the rough value I am giving, whatever rough value I am giving to that particular rough value, this PMTS plays very, very important role. So whatever the rough value I am giving, it is not given by the operator, it is not given by the worker. That rough value will be decided by the supervisor, or it is decided by the industrial engineer, the person who is having the maximum knowledge, he is having the vast knowledge about that particular job, about that particular task. That person can only give the rough value of that particular task. Here, the role of the operator is only to complete that particular job, to work on that particular machine. But whatever the rough value I am giving in advance, whatever the time I am deciding, that time will be given by that particular supervisor or the industrial engineer only, who is having the vast knowledge about that particular task, job, or that particular machine. Therefore, here by using the PMTS, I am not measuring the time in the second. In the time study, in the work sampling, I'm measuring the time in hour, in second, in minutes. But in case of a PMTS or in case of a PTS, I am not measuring the time in the form of second. Here I am using the time measuring unit. In short, it is called as a TMU. In case of a PMTS, I am measuring the time in the form of TMU. What is meant by the TMU? Time measuring unit. And here I have written 1 TMU is equal to 0.00001 hour or 0.036 second. Whenever I am using the stopwatch will give the reading, final reading in the form of second, in the form of minute, in the form of 1 hour. For example, 120 second, 5 minutes, 10 hour, 2 hour. Like that you will get the output in the form of time study and the work sampling. But in the third method, in the PMTS, I am not measuring the time in the form of second, in the form of hour, in the form of minute. So for that, special unit is designed, which is called as a TMU. TMU means time measuring unit. So based on this particular TMU, one MCQ based equation is there based on this particular chapter. 1 TMU is equal to, 4 options will be given: 0.001, 0.0001, 0.00001 hour, 0.01, like that 4 options will be given. From that we have to select one option as a 0.00001 hour. Sometimes 1 TMU is equal to 0.036 second, 0.00036 second, 0.36 second, 36 second, like that 4 options will be given. From that we have to choose the correct option as a 0.036 second. So this TMU is one unit which is used in the PMTS for the measurement of time. Here I am not measuring the time in second, in minute, in hour. Special unit is designed which is called as a TMU, which is called as a time measuring unit, and 1 TMU is equal to 0.00001 hour and is equal to 0.036 second. So this is about the predetermined motion time study, which is obtained from MTM concept. MTM means method time measurement, which is developed in 1948, and this PMTS is one of the application of this particular MTM, where in advance I am deciding the time, whatever the motions are taking place. For example, the operator number 1 is moving from one station to the second, second to third, third to fourth. So whatever the movement is taking place by that particular operator, that movement is recorded in advance by using the PMTS. For example, operator number 1, he has to move from work station 1 to 2, 1 minute is required. He has to move from second to third, 2 minutes are required. Like that, in advance, I am deciding the time, how much amount of time is required to move from one station to second, second to third, third to fourth. Like that, I am measuring the time in advance, and at the end, I am saying that total 30 minutes are required to the operator or to the worker to move from one station to second, second to third, fourth, third to fourth, fourth to five, like that number of workstations available in the industry. Therefore, in advance, I am measuring the time required to complete the task, or whatever the movements are taking place by the operator from 1 to 2, 2 to 3, that movements are also recorded in advance. Therefore, this concept is called as a predetermined motion time study, which is also called as a PTS. So what is meant by the PTS? Predetermined time standards. So this is the third method of the work measurement. So total 3 methods we have discussed in this particular chapter. The first method is called as a time study, second method is called as a work sampling, and third method is called as a predetermined motion time study. For that study, it is also called as a system. Study, it is also called as a system. Based on this particular PMTS, again one MCQ question is there. PMTS stands for, 4 options will be given. From that particular 4 options, we have to select the correct one in the form of predetermined motion time study, or predetermined motion time system, or predetermined motion time standards. So from that we have to select the correct option. You will get the correct mark. So these are the three methods which we have discussed in this particular chapter. And now we have to decide, or we have to discuss about the standard time. So now we have to solve some numericals based on this particular chapter, where we have to calculate the standard time. So whenever I have to calculate the standard time, I am having the formula. Standard time is equal to basic time plus allowances. So for each and every task, the allowance will be given. So different types of allowances we have discussed. Personal allowance is there, contingency allowance is there, interference allowance is there, policy allowance is there. Personal allowance means if I have to go for drinking the water, if I have to go for washing the hands, it will becomes under the category of personal allowance. Contingency means if there is a breakage of the tool is taking place, finishing of the oil is taking place. So like that allowances, it will be considered under the contingency allowance. Then interference allowance, again it is similar to the same, that is if I have to change the tools, if I have to take the rest, so like that allowance it will be considered under the interference allowance. And last we have discussed about the policy allowance. The policy allowance is totally depends on the management. If management wants to give the policy allowance, it will be given. But any worker, any operator, any supervisor, he will not be demand to the policy allowance. He can demand for the personal allowance, contingency allowance, interference allowance, but that operator should not demand to the policy allowance. If the management wants to give, management will be give. If management wants to not give, he will not be give. But why that particular allowance is required? Because whenever I am performing any type of task, in that particular task, I have to give or I have to add the allowance as per the requirement of the task. If I am working continuously for the 1 hour, in that particular 1 hour, 45 minutes is the time required to complete the task. Within 45 minutes, I can complete the job, but that extra 50 minutes are given in the form of allowance. In that particular 15 minutes, I can go for drinking the water. I can go for changing the tool. I can change the coolant. I can change the oil. I can replace the tool. I can go for washing the hands. All such types of the activities I can perform in the 15 minutes. Means 45 minutes plus 15 minutes is equal to 1 hour. This 1 hour is the standard time. 45 minutes is the basic time to complete the task, and remaining 50 minutes are the allowances which are given. Therefore, whenever I am calculating the standard time, so simple formula I am having, standard time is equal to basic time plus allowance. So here, whatever the figure I have represented, so this is the basic time. In this particular basic time is time required to complete the job only. In that 45 minutes, I cannot go for drinking the water, washing the hands. I cannot take the rest. For that 45 minutes, continuously I have to work on the machine without any mistake, without any delay, without taking any rest. So that time is called as a basic time. But along with that particular basic time, I have to give the number of allowances. So here one sample is given, that is relaxation allowance and the contingency allowance. So basic time plus relaxation allowance plus contingency allowance. If I will do the addition, I will get the standard time to complete that particular task. Therefore, whenever I am calculating the standard time, that standard time can be calculated by considering all the types of allowances, and it is necessary. So sometimes some heavy duty applications are there, some heavy duty jobs are there on which it is not possible to work continuously. Continuously we can work for 1 hour, 2 hours, but after that it is not possible to work. So after 1 hour, we have to give some allowance for drinking the water, for washing the hands. Sometimes if the operator is in fatigue, there is a maximum pain in his hands, legs, at his legs. So at that time, that operator has to take the rest. And once he has taken the rest, again he can start the job. Sometimes we have to go for drinking the water. Sometimes breakage of the tool is taking place. The machine is under the maintenance. Sometimes we have to change the coolant. Sometimes we have to change the oil. Sometimes we have to replace the tool also. So like that, unavoidable activities are there. So to that particular activities, we have to give some amount of time. Means I am giving the allowances. Therefore, whenever I am calculating the standard time, simple formula we have to remind, that is standard time is equal to basic time plus allowances. Basic time is time required to complete or to perform the operations only, and allowances in the form of personal allowance, relaxation allowance, contingency allowance, policy allowance if applicable. So like that, all the allowances we have to consider along with basic time, and we have to do the addition, and that addition you will get the total standard time. That's why I have given the example. 1 hour is the standard time. Out of that 1 hour, 45 minutes are the basic time in which we are performing the operations only, and remaining 50 minutes are given in the form of allowances. That means in that 15 minutes, I can go for the drinking the water, I can change the tool, I can change the oil, I can change the coolant. Like that, unavoidable activities can be considered along with that particular basic time. If that allowance will not be given, it is not possible to work in the effective manner. जर आपण allowance दिलाच नाही, तर it is not possible to work in the effective manner. Always the workers are in fatigue, they are not working in the effective manner, and automatically it will be affects on the overall production, it will be affects on the overall productivity. Therefore, this allowance will be given along with basic time, and by that addition I can calculate the standard time required to complete that particular task. So this is about the standard time calculation. Based on this, we have to solve the numericals, but that numericals we will take in the next lecture. So with this, today we will stop here. We are having the 3 numericals based on the standard time calculation. That 3 numericals we will take in the next lecture. So now I will take the attendance. Yes, roll number 1. 2.
Present, sir.
3.
Present, sir.
4. 5. 6. 7. 8. 9.
Yes, sir.
10. 11.
Present.
12. 13. 14. 15. 16.
Yes, sir.
17.
Yes, sir.
18.
Yes, sir.
19. 21.
Yes, sir.
22. 23. 24. 25. 26. 27. 28.
Yes, sir.
29. 30. 31.
Yes, sir. 31.
32. 33.
Yes, sir.
34. 34. 35. 36. 37. 38. 39. 40.
Yes, sir.
41.
Yes, sir.
42.
Yes, sir.
43. 44. 45. 46. 47, 48,
Yes, sir. 48.
49,
Yes, sir.
50, 51,
Yes, sir.
52,
Yes, sir.
53,
Yes, sir.
54, 55,
Present, sir.
56, 57, 58,
Yes, sir.
59,
Yes, sir.
60, 61, 62, 63,
Yes, sir.
64, 65.
65, yes, sir.
Who is remaining?
Sir, roll number 5.
5.
Roll number 60,
Next.
sir.
50.
60.
57.
Next. Hmm?
Roll number 25, sir.
25. Next. Those who have given the present, they can leave.
57, sir.
57.